All right, guys, you are starting Unit 6 in 6th grade. We have Unit 7, and we'll be done with 6th grade, moving on to 7th grade. So we are getting there. All right, so this unit is all about data, collecting data, the different types of data, ways to show data on graphs and charts. So let's get started. It said data is collected information about a given topic. Oh, let me get my clicker going. Collecting data can help someone learn more about a particular topic and also help them make decisions. Data can help someone prove things. The study of data is called statistics. Data can be collected several different ways. The most popular ways are through surveys, through interviews, through research, etc. A statistical question is a question that guides research by defining the population of a given topic and that participates a variety of answers in the collected data. So what does that mean? So let's say I want to know what people do on the weekends. Okay, so I could come up with a good survey question. I could stand at the mall and I could ask every third shopper that comes into the mall, hey, what do you do on the weekends? Now, it would only be a good survey if probably not the mall, because if I went to the mall on a weekend and was asking that question, that could be considered a biased survey, right? So I wouldn't really need to go somewhere that's really very neutral, or even better might be like a telephone survey or a mail-in survey for people to answer. Because if you ask people what they're doing on the weekends, and if you are collecting this information on the weekend, wherever you are might definitely cause that survey to be biased. For example, if I wanted to know, do people go to the movies on the weekend? Well, I wouldn't take that information standing outside a movie theater at the mall on a Saturday, right? So anyway, when you do collect data, when you ask a survey question, you want to make sure it's unbiased. Another example of how not to take a survey would be to come up with a question like, what is your favorite game, or what's your favorite sport? And you ask people who were at the basketball game. That would be a biased survey, right? Because obviously most of the people there would be there because they enjoy basketball. So, but this is emphasizing how when you ask a survey question, there needs to be a lot of different answers. So for example, if I went up to someone and I said, how old are you? Well, there's only one answer to that question, right? So asking someone specifically their age that's not a good survey question, because when I ask, how old is John? Well, there's only one answer. John is a specific age, right? But if I said, hey, I need you to go to your local mall, and I want you to find out what the average age of shoppers are at this particular store, well, there could be people there of many, many different ages. So that would be a better survey question, right? But if you ask a question and there's only one exact answer, that is not a statistical question, okay? So let's look at some examples of statistical questions. That means when you collect data, people can give you many different answers. All right, so if I said, what is the favorite color of all your classmates? That means you're asking everyone their favorite colors, and everyone has many different choices, right? They could say blue or yellow or orange or magenta or all kinds of whatever colors. There's lots of colors in the world, right? How many pets do the people in your city have? So you're not asking exactly how many people, how many pets are only in one home, because there's only one answer to that. You're gathering data from a big area. So there could be people with 0 pets, and someone else could have a farm and they could have, I don't know, a lot. So baby goats, 30 baby goats, I don't know. How many miles do your classmates live from school? So once again, a lot of different answers to that question. What is the favorite video games of 6th graders? So you're collecting data and you're coming up with the favorite video games out of many video games to choose from. What grades did 3rd period students get on their homework? Well, once again, you're asking a lot of people, and a lot of people could have different grades. So you're collecting information that there are many different answers to. Now, these are non-statistical questions. Non-statistical questions is when there's only one answer. For example, if I said, what color is Jane's purse? Well, there's only one answer to that question, right? Even if it's a multicolored purse, that's the only answer. It's a multicolored purse. What is the class average on homework in 3rd period? Now that's different from this question, right? This one's asking for one average for the whole class. Well, there's only one answer, so that is a non-statistical question. How many pets does Jeff have? How many sticks of gum are in a regular pack? Well, if it's a regular pack, that means that it's a regular pack because that pack has this many specific types of gum or numbers of gum sticks, whatever. All right, so anyway, I hope that helps. So if there's lots of answers, good question. If there's only one answer to your survey question, it's a non-statistical question, okay? All right, the other thing you're looking at this week is how data is distributed. So all three of these, so first of all, this is a histogram, this is a line plot, and this is a box and whisker plot. And by the end of this unit, we're all going to be making all of these types of graphs. But you notice that if I followed the curve of these lines, I have what they call a bell shape. And bell shapes are called statistical, okay, or symmetric. Not statistical, symmetric, that's the word I was trying to think of. So if you have a bell-shaped curve like this, that is symmetric because both sides of the picture, if you fold it on top of each other, it would match, all right? Same thing as this line plot. We have that nice symmetric bell shape there. And this box and whisker plot, if I bent it or folded it where that red line is, they would match up, both sides would match up. The other type of data distribution is if you have uniform. That means every answer had the same number of responses. So 10 people said 10, 10 people said 20, 10 people said 30, so on and so forth. So this histogram is uniform, this dot plot is uniform, and this box and whisker plot is uniform. All groups have the same distribution of data. We also can have what we called data that is skewed right. So if you follow the shape of these bars, this shape is going to skew down right. It's skewing down right. Do you see that? It's getting smaller as you go right. Same thing with this line plot. If I follow the shape of the distribution, it is skewing down right, like that. You see that? Here, our box and whisker plot, this part of our box and whisker plot represents 25% of our data. This represents 25% of our data right here. So 50% of our data goes from here to here, and then this whole section is 50% of your data. So it is skewed right. If you got a long whisker on the right side, it's skewed right. If your whisker is long on the left side, it's considered skewed left. And that's what all of these are. So we find the most dense part of our data. Oops. And we see that it goes down to the left. So we're following the curve, it skews left. Same thing here. This is the bulk of our data. And as we go left on the number line, our responses are getting less and less. Once again, this is 50%. So we got this long whisker right here. This is 25% of my data, this wide open gap between the last 25% of my data. So that is skewed left. And then a few more examples of those. If you get confused, some people want to say it's opposite. It seems like the data is what do you call it? Like it's all condensed to the left. So some people think it's skewed left, but no. As the data gets less dense, less popular answers, this is skewed right. This one's skewed left, okay? Same thing with this dot plot. I think I actually cut off some of those dots on accident. It's definitely skewing right, okay? And this one is the opposite. And this little answer way down here by itself, off from the other one, is called an outlier. We'll talk about that this unit. And once again, those box and whisker plots, we have our long whisker on the right compared to the length of this one. And then the opposite is true. Uh-oh, I just turned it off. All right, so that's what you're talking about this week. You are figuring out if questions are statistical or non-statistical, and then you're talking about the distribution of data, and that'll get you started this week. And then next week, we'll move on with a little bit more data. So you guys have a good day. If you have any questions or need me, let me know.